Hi students, welcome to online classes. In this semester, I am going to teach you switchgear and protection subject. Subject subject code is 1620501. In this lecture, we are going to see fundamentals of switchgear and protection. Okay. My name is Vijay Bhaskar. I am working as a lecturer in electrical department, James Sporting College, Automobile. Now we are going to see the word switchgear. Switchgear means, what is meant by switchgear? If you see this, switchgear is a compressing word. It includes circuit breaker, switch, fuse, isolator, current transformer and potential transformer, relays, contactors, all these things. switchgear मतलब ये होता है, ये सब मिला को हम लोग कहते हैं switchgear. स्विचगियर मतलब ये एक अकेला इक्विपमेंट नहीं है. मान लीजिए एक स्विच हो गया, नहीं तो एक फ्यूज हो गया, ऐसा एक अकेला नहीं है. ये स्विच, फ्यूज, आइसोलेटर्स, रिले, सर्किट ब्रेकर सब मिला के हम लोग कहते हैं स्विचगियर. ठीक. सो नाउ विल सी अहेड. हम लोग का क्या जरूरत है? नेसेसिटी एंड फंक्शन ऑफ प्रोटेक्टिव सिस्टम. ये प्रोटेक्टिव सिस्टम हम लोग स्विचगियर में हम लोग इतने सारे प्रोटेक्शन यूज कर रहे हैं. व्हाट इज द नीड ऑफ दिस प्रोटेक्शन? टू सी, to protect the entire system from the faults, we need this protective system and continuity of supply. बिना रुकावट हम लोग को बिजली आना तो हम लोग को ये चाहिए. नेक्स्ट, energize and de-energize the circuit. In order to on and off the circuit, we need this switchgear system. Here you can see, this is one bus bar. Bus bar means it is a transmission line. From here we are sending supply. Here you can see this is the supply we are sending. So here we kept one circuit breaker. This is the circuit breaker. This circuit breaker, inside this circuit breaker we have one trip coil. This is the circuit breaker. Okay. In this transmission line, this is one outgoing feeder, means from this bus bar we have connected one feeder. We are taking one feeder, we are sending to one city. Suppose the fault is happened here, and the fault occurred here. So in this line there is one current transformer. This current transformer, what it will do? This current transformer, what it will do is, it is going to record the current value continuously. Here we can see. So when the current value exceeds certain limit, see here I set my current transformer for 50 amperes. If the current in the transmission line is more than 50 amperes, I set the value to activate this. So immediately this relay coil is going to energize. So when the coil energized, this is going to pull it down. ये नीचे खींचेगा, तब क्या होगा? ये नीचे आएगा, यहाँ बंद हो जाएगा. When it is closed, here we can see DC source. This is the DC source. Nothing but when we close this, we have switched on this one. जब हम लोग इसको चालू करेंगे तब क्या होगा? यहाँ एक ट्रिप कॉइल भी एक्टिवेट हो जाएगा. ये सर्किट ब्रेकर को बंद मतलब ओपन करेगा. अभी सर्किट क्लोज में है पहला. When the coil is activated, it is going to open the circuit. So this is how the total system is going to work. By mixing all these, we say it is a switch gear. Next, we are going to see normal and abnormal conditions. Normal conditions mean Here you can see all the electrical parameters such as current, voltage, frequency, power factor, etc. are within the limits are called normal conditions. Here we can see all the parameters. In electricity we have different parameters: current, voltage, frequency, power factor. So I set a system to work at 10 amperes, 230 volts, 50 hertz. This is my system. I have set my system to operate at this ratings. Otherwise I can say these limits. See, if the system is exceeded the values, okay, if suppose the current is 11 amperes, I will say this is the abnormal condition, okay. Otherwise, if suppose the voltage is different, voltage is varying. Now this is the set value, otherwise you can say limit value, okay. If suppose here we can see that, then here is 10 amperes, 230 volts and 50 hertz, then I will say system is normal, okay. If next abnormal means here we can see when the electrical parameters are violated the limits, it is called abnormal condition. Here you can see I have set my system to work at normal, this is set value, or I will write limit value. This is the limit value, okay. Now this is the normal. Now if suppose the current is 11 or 9, means either above 10 or below 10, and voltage is 231 or 229, okay. You can say 230, इससे ऊपर है नहीं तो नीचे, इसको कहते हैं हम लोग abnormal. So here you can see if it is within the limits, हम लोग जो लिमिट सेट किया है ये लिमिट के अंदर है तो इसको कहते हैं हम लोग नॉर्मल. अगर ये लिमिट से पार हो रहे means if it is violating limits, you can say it is abnormal condition. Abnormal condition in power system may be caused by transmission line fault, generator fault, or any other faults, overloading, switching of device, etc. So it may be happen due to time faults in transmission line or faults in generator. Otherwise, if you overloaded the system, then also it will happen, and due to some switching of device. If suppose 100 amperes load is going on, if we switch it off immediately, then abnormal condition will fault. Fault means here we can see A fault in an electrical equipment is defined as a defect in its electrical circuit due to which the current is diverted from the intended path. Here I will explain. We have designed a transmission line to take the current in this. So here I will mention this is my circuit. Okay. Here I designed current to flow in this. This is the phase and neutral. Okay. Due to some fault, actually current is flowing in line. If suppose due to some fault, if the current is diverted from this line and if it is flowing through neutral or the line fell down on the ground, you can say there is a fault in the system. This we can see here, current is diverted from the intended path. जो पाथ हम लोग डिसाइड किया है करंट जाने के लिए उससे बाहर जा रहे तो करंट, इसको कहते हैं हम लोग फॉल्ट आ गया. Types of fault on the causes we will see. We have total 8 types of faults. Here we can see. First one is active fault, passive fault, transient fault, permanent fault, symmetrical fault, asymmetrical fault, open circuit fault, short circuit fault. Now we will see one by one. First we will see active fault. Active fault means, if we see, this will happen between the phase to phase or phase to earth conductors. These faults are further classified into 2 types: solid fault and incipient fault. Solid fault and incipient fault. During this, current will flow from phase to phase or otherwise phase to earth. Suppose we have RYB line like this. This is the RYB line. Current may flow from phase to phase. Current will flow like this. Otherwise, current will flow from here to ground. This we can say active fault. This further classified into 2 types: solid fault and incipient fault. Here we can see solid fault. Solid fault means if the fault occurs in the system, it is a solid fault, it is going to break down the system immediately. When the fault happens, suppose the line is going like this, the fault happens, immediately it will break down the system, total system. We say this fault is a solid fault. Incipient fault. Incipient fault means, if suppose we will take one transformer, inside the transformer we have core. This is the core in transformer. What the core will do is, it is a rectangular box. On this we are keeping windings. It is filled with oil. Suppose there is some fault in the transformer, what it will do is, the transformer is going to be create some fault. This we say incipient fault. Means ये पूरा breakdown होने के लिए based on the severity of the fault. If suppose the transformer is designed for 50 kVA, if we are operating this transformer on 60 kVA, मतलब ज़्यादा लोड डाल दिया हम लोग, तब क्या होगा, ये ज़्यादा हीट हो जाएगा, लेकिन तुरंत खराब नहीं होगा, 1 महीना तक ऐसे ही काम करेगा। 1 महीना के बाद ये पूरा ब्लास्ट हो जाएगा, नहीं तो पूरा ऑयल एक्सपेंड हो जाएगा, ऐसा ज़्यादा फॉल्ट आएगा। इसको कहते हैं हम इंसिपिएंट फॉल्ट। Here you can see, I give example. Next one is passive fault. Passive faults are not real faults in the true sense of the word, but are rather conditions that are stressing the system beyond its design capacity, so that ultimately active faults will occur. Typical examples are, if suppose here you can see this is not a active fault. I already told we have designed a transformer to work under the 50 kilovolt ampere. If we are using this 50 kilovolt ampere transformer to operate this load, this we say it is a passive fault. हम लोग ऐसे ज़्यादा ये 10 kVA ज़्यादा यूज कर रहे हैं ना, ऐसा कुछ महीना और कुछ दिन यूज करने के बाद ये ब्रेक डाउन हो जाएगा, इसको कहते हैं पैसिव फॉल्ट। इन दैट पैसिव फॉल्ट वन इज ओवरलोडिंग एंड ओवर वोल्टेज। वी हैव डिजाइन ट्रांसफार्मर टू वर्क अंडर 11 kilovolt. If you are operating it at 12 kilovolt or 11.2 kilovolt, this is also over voltage. Like that, if you are going beyond the voltage limit also, it is a passive fault. Next, under frequency, or we can say over frequency also. Power swings, and this power swing also should not be there. Power swing मतलब power ऊपर नीचे आना है, ज्यादा होना है, कम होना है, ये भी नहीं आना चाहिए, इसको भी हम लोग पैसिव फॉल्ट कहते हैं। Next one is transient fault. Transient faults are faults which do not damage the insulation permanently and allow the circuit to be safely re-energized after a short time of period. Here you can see, first we need to understand the term transient. Transient मतलब ये होता है, मान लीजिए मेरे पास एक जनरेटर है, एक टाइम है 1 second, 2 seconds, 3 seconds, 4 seconds, here suppose 1 hour. Okay, like this we have scale. When you switch on generator, here we can see 100 volt, 200 volt, 300 volts. So here you can see at first second the voltage will reach to here, at second voltage will reach to here, and if I am taking this as a single phase generator, the voltage is constantly 230. Okay, 230 volts. This time, here you can able to see it. Yes, this time we will say transient time. Okay. Transient means it will be there for a short period of time. Transient means it will be there only for a short period of time. If suppose the fault happened here at this point, the voltage may come down up to suppose 190. and within 1 or 2 seconds it will go back to here. Suppose it may go to 250, but it will come back within 1 or 2 seconds. this ये छोटा से टाइम में डिस्टर्ब हो जाएगा लेकिन तुरंत अपना से ठीक हो जाएगा, इसको कहते हैं ट्रांजिएंट फॉल्ट. नेक्स्ट वन इज परमानेंट फॉल्ट. परमानेंट फॉल्ट मीन्स it will not come under the control. When the fault happened, it is going to break the system completely. This we say permanent fault. Here we can see permanent fault, as the name implies, are the result of permanent damage to the installation. In this case, the equipment has to be replaced and reclosing must be entertained. During the permanent fault, when the voltage is like this, suppose in generator, it is going like this. At this fault condition, the voltage will come down to 0. At this condition, we cannot switch on the circuit. We have to, if suppose it is short circuited, we have to change the wiring, we have to change the insulation. Like that, we need to do repair, and if there is any need of replacement of equipment, we have to do. After that only we can go for the operation. This is permanent fault. Next one, symmetrical fault. Symmetrical fault is the balanced fault. If when the fault occurred on the transmission line, here we can see symmetrical fault means when the fault is happened between line means इसको कहते हैं हम लोग 3-phase fault or 3-phase to ground. 3-phase to ground. 3L means line. एक line R, Y, B. This if fault happen between the 3 lines, we say that is symmetrical fault. If the fault is symmetrical, the resultant current is going to displace with 120 degree. Here we can see the fault current will displace with 120 degrees. These are the example for the symmetrical fault. Here we can see this is the R, Y, B. So fault happened between, here short circuit happened between R, Y, B. So we can say this is a symmetrical fault. Here the fault happened between R, Y, B and the line fell down on the ground. This is also symmetrical fault. Next one is asymmetrical fault. Asymmetrical fault means जो हम लोग पहले 2 देखा है उसके अलावा कुछ भी फॉल्ट आने दीजिए, इसको कहते हैं हम लोग asymmetrical fault. Here we can see एक लाइन नीचे गिर गया, इसको कहते हैं हम लोग asymmetrical. और 2 लाइन के बीच में शॉर्ट हो गया, नहीं तो 2 लाइन के बीच में शॉर्ट होने के बाद गिर गया, इसको भी कहते हैं हम लोग asymmetrical fault. Or we can see this next one is open circuit fault. This open circuit fault, here we can see there is a open circuit at R phase. This one is single phase open circuit. The open circuit happened between, यहाँ R में ओपन हो गया और Y में भी ओपन हो गया, इसको कहते हैं हम लोग 2 फेज. अगर तीनों के फेसेस में ओपन हो गया तो इसको 3 फेज ओपन सर्किट कहते हैं. Next is effects. If the circuit is open, in this circuit there is open circuit fault, what is the effect? First one, abnormal operation of the system. In the system, abnormal means the values will go high, voltage ज़्यादा हो जाएगा, ऐसा आएगा. Danger to the personal as well as animals. If suppose a line is like this, from here there is a tower, this is one electric pole, this is connected to the generator. So when we are taking like this, यहाँ open circuit हो गया, मतलब ये यहाँ से गिर जाएगा, so line will fall down on the ground. When we touches this transmission line, we don't know, हम लोग को पता नहीं इसके ये अभी चालू में है, बंद है, लेकिन many times it will be on condition. When we touches this conductor, we will get shock. गलती से कोई जानवर इसको छुएगा, वो एनिमल भी मर जाएगा. इसके चलते ये ओपन सर्किट फॉल्ट डेंजर है. Exceeding the voltage beyond the normal values in certain parts of the network. I already told in abnormal composition. During the open circuit fault, the voltage levels will be very high. Next, short circuit fault. Here we can see short circuit means there is a low impedance between 2 points. इसके चलते हम लोग को शॉर्ट हो गया. यहाँ फेस सिंगल फेस टू एर्थ, एक फेस गिर गया धरती पर, नहीं तो 2 फेस टू एर्थ में 2 कंडक्टर्स has fell down. Otherwise, one more fault is between face to face and one face to earth. These are the different types in short circuit faults. What are the causes of this short circuit fault? This may be due to internal or external effects. कभी कभी हम लोग डिजाइन किया है, लेकिन ये डिजाइन में गलत है, इसको कहते हैं हम लोग इंटरनल इफेक्ट्स. मान लीजिए हम लोग इंसुलेशन जो यूज किया वो कम से कम 20 साल तक करना है, 20 years, लेकिन थोड़ा गड़बड़ होने के चलते ये 15 साल में ये खराब हो गया, तब इसको कहते हैं हम लोग इंटरनल फॉल्ट. एक्सटर्नल फॉल्ट मतलब because of we designed a transmission line like this during the rainy condition, बारिश के चलते एक पेड़ का ब्रांच इसके ऊपर गिर गया, तब ये कट हो जाएगा. इसको हम लोग कहते हैं एक्सटर्नल इफेक्ट्स.